when I asked Tom to come to this, I said, in the note, I said, I thought you could provide the voice of pragmatism in terms of research. Tom's been,
Well, I'm not sure.
you've been up to your eyeballs in the snake pit for some time on this.
Well, this is a more broader perspective, and it touches on aspects that have been discussed throughout the day. Just some parameters in terms of, I'm using the example of Canada, where we have a lot of overburden drift, glacial overburden, but part of that can be used because it's really just ground up rock flour, and some excellent studies over the years at Geological Survey of Canada, Harvey Thorleifson, Beth McClenaghan, and others have shown good application of indicator minerals, which reflect the bedrock that lies underneath. And the one thing we learn is bringing experts together to learn from our history, from case examples and so forth. So I've listed a bunch of points here in terms of how can we do better at looking under the cover. And as John mentioned, a number of junior companies really don't have the wherewithal to go into detail in the geophysics. So I asked one of my friends who's worked for about 4 companies, and he said we always standardly do magnetic maps and so forth, but we don't really get a lot out of it in general. And he said he'd like to see more methods of cheap drilling or bedrock testing, low-cost boreholes, and this goes back to what's been the DET project in Australia. Some of the creative explorationists up in the Yukon were developing land little vehicles which went out and sampled various samples around the Klondike area, and were very productive in finding the actual in situ gold up there. So it's really that kind of cleverness, lightweight drills. We're doing some tests with those in the Northwest Territories. So we really need more geological control to get more control on what are the geophysical features and what do they mean. Secondly, for truthing surface and airborne geophysics, we need more in situ borehole logging and more processing of the data, and as well rock properties of core. And this has been, I know DGI, Geophysics, or Geosciences, has been doing this in particular areas. It's kind of hit and miss in terms of how many companies are dedicated to this, but I think you get better interpretation of the geophysics from that. As well, we have a lot of examples of fairly widely spaced sampling of regional geophysics, in particular the gravity surveys over 10-kilometer spacing or something like that, and then sort of 800-meter spaced magnetic lines. And some of the surveys, such as let's say the Saskatchewan survey, supported flying the Athabasca Basin with high-resolution geophysics, and that seems to be pretty productive. They're integrating that with a lot of 3D geology, and so that's a very good compilation project. Now, I think there has to be better use of the regional geochemistry. We have kind of sporadic coverage of lake sediments, and I worked in Newfoundland for quite a while, and the Newfoundland Labrador Survey flew the entire province, including Labrador, with lake sediment surveys, and the values we get out of that really reflect the bedrock, and also drove a lot of mineral exploration in gold, tungsten, and various other elements. As well, stream geochemistry was quite productive in the Bathurst camp, and the discoveries there, and in British Columbia. I think some of the broad areas in Labrador or the western Ontario and west of the Lake Superior, there's a broad area of coverage of lake sediments, and there's an opportunity there to test really the application of that in a thorough study to see how can we do better mapping of the basement with that kind of data. The other thing which I mentioned earlier was the indicator mineral surveys, which have been, there's quite a large archive in Ottawa and other places. The Ontario Geological Survey has archives. This is obviously from the kimberlite exploration been shown to be very applicable, and I think really we have to work with some of the other indicator mineral suites to understand really what we can do with those minerals in terms of targeting, understanding regional patterns or distal patterns around mineralized areas and so forth. In BC, just recently, they did work with apatite related to porphyry intrusions. Next page. Oh, I've got it here. Excellent. There we go. And the other thing is, I've been related to a survey that's presently going on in the Northwest Territories, and they're doing a number of government mappers and university mappers are mapping the superficial geology around the kimberlite deposits. And what we see there is quite a bit of variability, and that's also reflected in the populations of indicator minerals, and maybe as well reflected in the geochemistry from the finds within the till. We don't really know what that data is like at the moment. What we're seeing there as the glaciers retreated about 20,000 years ago, there was a lot of ice melting and melt channels. So this kind of disrupted the pattern of sort of the standard basal till. Some of the last glaciers that moved over actually distributed materials out of the Hudson Bay, and that covers actually the local tills above. So these all are affecting the kind of mineral concentrations and elemental concentrations in the cover, and we have to understand more of that. Also the extensive lake sediments that cover a lot of those areas as well. So there's a lot we have to learn about the variability of anomalies within the cover. The other areas I find kind of interesting are these very broad, extensive alteration areas, which Glenclory was an example of that. But we have areas like that in the Great Bear region in the northwest of Canada. And as around the Sudbury region, large parts of the Huronian Basin from Lake Superior to over to Quebec have a lot of sodic alteration. And as well, there is hematite, silica flooding, magnetite in places in there. And we really don't understand what that event was. And I think there are other areas in Canada which have similar broad alteration zones. Another one I can think of is the Ottawa Basin, or the Ottawa Fault Graben, going northwest from Ottawa up the Quebec border. And that's coincides with the cobalt, silver cobalt camp, which was mined years ago before we really got to advanced scientific levels. And what's the meaning of the broad alteration related to that? So I think that may guide us if we pay more attention to those regions and start trying to understand. The other topic is just the greater need for more integrated regional compilations with more geochronology and event paragenesis. This has been done in specific areas, such as the Thompson-Nickel Belt or the Athabasca Basin, but I think we need more of that to guide us in terms of targeting. Then really looking at the areas where we should have potential for finding significant mineralization. There's been a fair bit of success looking at the edges of major districts. And I think of the recent exploration by Ivanhoe in Africa, where they worked at the edges of the copper belt and the edges of the bush belt with great success. To a lesser degree, you can see in some of the districts in Canada around Meadowbank and the Detour Lake area, just more recent exploration around the edges there have found higher grade gold mineralization. So it's something to keep in mind. And lastly, I think this was referenced to by Dan earlier, was the, really we need to know more the parameters of the major world gold districts and how this can guide us. We have a fair bit of information on that already, and just continue to build that. And I think this is where that program like Metal Earth could come in quite well, in that it's putting a big emphasis on unendowed regions and what is the difference between that and mineralized areas. So anyway, those are some broad suggestions for working with the cover in the Canadian context. Thanks.